Alright guys, it's Hoffbauer here and I am still home on quarantine while I'm making this video. Hopefully I'm back with you by the time we play this video. I am going to go over some more equation solving, but yesterday's video kind of ended up long, so what I'm going to do today is try to do the hard problems that I didn't do any of yesterday, and then if you want to stop the video, you can. I'll go back through some of the easy ones a second time for those of you who need some more practice, but I'm going to kind of skip around. This is at the top of your notes. The first principle it talks about is the one-to-one. It says if you have, it's supposed to say this, and I think it's fixed on your notes, but I don't know. If you have the base the same, then the exponents have to be the same. And some teachers would say that you would exponentiate both sides. Okay, so this could be rewritten where the bases are the same. I did some like this yesterday, so I'm not going to do too many of these today, but you could actually rewrite both of these as powers of 4. So if you wrote this as 4 to the x minus 1 and this as 4 squared, you could also make them powers of 2. Whoops, and this one has an x out here. So these would multiply, and you could say the exponents had to be equal. So x minus 1 would equal 2x. Subtract an x from both sides, and you get x equals -1. If you put it back in, you get 4 to the -2 equals 16 to the -1. Which would be 1 over 4 squared equals 1 over 16, so that works. Just proving to you that it works. Okay. This is the tricky kind that I wanted to spend some time on. This requires what's called a U substitution. We are going to factor this. We're going to let this term right here represent U. So if U is an e to the x, then U squared is an e to the 2x. We're multiplying both exponents by 2 here. So this is a U squared minus 3U plus 2 equals 0. Nitro, that's enough. You're making noise on the video. This would factor U minus 2 and U minus 1. So you get U equals 2 or 1. The problem is we're not done, because remember U was e to the x. So this is e to the x equals 2 or e to the x equals 1. Now to solve for x, we still need to take the log of both sides. So if we take the log of this, we can bring the x out in front, and we take the log of this side. That's a 2, sorry. And over here, we can do the same thing. So this is 1, and this is 1. So we have x equals either the natural log of 2 or the natural log of 1. Now, you can also approximate those with decimals, but those are the exact answers. This would be 0.6931, and this would be 0. So if you put a 0 in, you'd have 1 minus 3 is -2 plus 2 is 0. But the natural log of 2 also works. So these are kind of weird and tricky, and to be super duper honest, I didn't put one on the quiz, but we are going to practice them. I think you need them for calc, actually, to be able to do some derivatives of these. All right. These are both pretty basic of what you did yesterday's video, so I'm going to leave those, and actually they're worked out here for you even better. This are what we like to call baby bases. If we rewrite this as a 3 squared, then you would just set those equal. This is a 2 to the -2. And this is a 2 to the negative 3, because 2 to the third, and so those are both powers of 2. But you got to remember, I'm sorry, my wind chimes are probably picking up on the video too, that you have to distribute this and solve, okay? I don't think there's anything tricky about this one. All right, I'm gonna shut the window so you don't have to listen to those. Hopefully don't pick up as much anyway. If I add 33 over here, I get 35. If I add 4x over to this side, I get 7x. So I get x equals 5 for that one. All right. This one is kind of like that, so I'll skip it and go back and do it on the notes. All right, here's another one where we're going to factor. We're going to say e to the x equals u, which means e to the 2x is a u squared. So we have 2u squared plus 12u minus 54 equals 0. We can take a 2 out of all this and really just throw it away, because if we divide both sides by 2 right here, this divides out. So then we have u plus 9 and u minus 3. So we get u equals negative 9 or u equals 3. But remember, u was really e to the x. Now, this is where you have to remember something. If you take the log of both sides, can you take the log of negative 9? The answer is no, this is not possible. Over here, when we take the log of both sides, this is going to be our exact solution. This is 1, so we have x equals the natural log of 3. They're showing here that if you graph this is a different question, but if you were to graph this, okay, put all this in your calculator and figure out where it equals 0, it would have 1, 0, and that 0 would be at the natural log of 3, or about 1.0986, okay? Those are tricky. All right, there's no way to write these both as the same base, so you're going to have to take the log of both sides. Then you can bring the 2x out in front. Then, honestly, to get x all by itself, you could just divide here. The log of 12, if you divide both sides by 2 times the log of 9, okay. Well, that's a hot mess. The problem is you have to divide by both of these, so I usually do it in 2 steps. Otherwise, you need extra parentheses. Okay, I would have done log of 12 divided by log of 9, and then that divided by 2. Otherwise, this works if you put all those parentheses in, so just make sure that when you type it, you close this parenthesis, then you do divided by a giant parenthesis, 2 times the log of 9, close some parentheses, you get this answer. All right, this is very similar. You're taking and dividing first to isolate, and then whatever this is, I'm not even going to bother to type it yet. And then to get rid of the ln, you're going to take the natural log of both sides. And this will come out in front. So because the log of e, natural log of e is just 1, we end up with this. So we type this in and then we add 6 and we're done. The natural log of 9.3 divided by 2.4, and then plus 6. All right, so I finished both of those. This one's ugly because I can't rewrite this, so I have to do the log of both sides, and it doesn't matter which kind of log I do. If I take, and I can bring that out in front. Now, I usually do a little bit of maneuvering here. You can distribute this and make it all decimals, and it's just going to be ugly, okay? So if you multiplied over here, 2 times the log of 3, you get 0.9542, and that has an x. And over here, if you do the log of 6, it's 0.7782, and then it's also back here minus 1, so it's 0.7782. There's not really a nice way to do this, okay? And then if you subtract 0.9542 minus 0.7782x, you get 0.1760x equals negative this guy, and then we got to divide. I got negative 4.4216. So if I go back and type that in, so if I do 3 to the power of, and I put 2 times negative 4.4216, I get almost nothing. I get 6.035 times 10 to the negative 5th. On the other side, if I go 6 to the power of negative 4.4216 minus 1, I get almost exactly the same thing. Okay, so it is checking when I put those back in. They're just really ugly. I'm going to skip that one. I'll do it in the notes. The next property is the log property, one-to-one property of logs. So it says if you have, for example, the log of 3x equals the log of 7, the only way that's true is if 3x equals 7, okay? If the log of this equals the log of this, then the a and the b have to be the same. So this is not that kind. Okay. Well, this kind, you would isolate this expression first. So you'd add 1. I have a feeling this one's already done. Then I would divide both sides by 2 so that you have the log base 5 of 4x. That is supposed to be a 5 down there. Equals 6. Then you can do each power, each to the base 5, which this will undo each other. But remember, Hofbauer just thinks about it. That step right there said log base 5 of 4x equals 6. I just think about it as 5 to the 6th power equals 4x. I just rewrite it using, remember from our video, log base b of a number equals the power b to the p equals n. So I just rewrite this. But you can also think of it like this. You still get 4x equals 5 to the 6th. So then you do 5 to the 6th power, which is a big number, and divide it by 4. And we get x equals 3906.25. I hope that's what it says here. Yes, it does. All right. This second example, because this guy doesn't have a log, we can't do anything with that. So I'm going to move the logs over to one side. Equal to 5. And then because it says plus, I can multiply them. I have to condense them into a single log. That's the whole reason we had to learn that silly section on property of logs. All right. Then when we combine these, we're going to FOIL this in here. and get a 2x squared minus 12x. And if we have the log base 2 of that equals 5, you have two options. My idea would be just to rewrite it, or some teachers do that guy. So this undoes itself, or we just rewrite it as 2 to the 5th equals, okay, it's the same thing, 2 to the 5th on this side, this guy, whatever order you want to do it. 2 to the 5th is 32. At some point, we want to get it equal to 0 and take out an x, a 2, I mean. So I'm kind of cheating steps here. And then this will factor x minus 8, x plus 2. Now, some of you like to say that this 2 is a 0, but it's not. 2 does not equal 0. This, well, I shouldn't draw x over it because that looks like an x, not a... where's my undo button? All right, let me just write it down here. 2 cannot equal 0. X minus 8 equals 0 will make x 8. Nitro! X plus 2 equals 0 will make x negative 2. So I have 8 or negative 2. If I'm going to have to stop the video, obviously. All right, so I had 8 or negative 2. I have to go way back up here to the top, though. And if I put a negative 2 in here, I would have the log base 2 of negative 8, which is not possible. You can't take the log of a negative number. So if I put a negative 2 over here, I'd have log base 2 of negative 4. Doesn't work. So the negative on this one gets thrown away. Please don't assume every negative gets thrown away all the time, because that's not true. But here, the only solution we have is x equals 8. This one was extraneous, meaning it doesn't check. All right. All right, here's the easy kind. When you have 1 log equals 1 log, you can just divide these out and you get 3x equals 12, x equals 4. But that does not work over here. You can combine these, okay? And a plus means times, so you have log base 12 of 2x. And then, and only then, do you have 1 log equal to 1 log, and you can divide that out, or remove that, undo that. You have, what did that property call it? The one-to-one property of logs, okay? If they are equal, then the quantity here is equal. But again, somebody is going to try some funkiness, like divide this all out, take that all out, and they're going to write 2 plus x equals x plus 7. Well, that has no solution, first of all, okay? So don't be trying that. All right. Oh, I will do this one in the notes. This is just disgusting because they're such big numbers. You would have to multiply this. And then you can get rid of those, foil all this together, and it gets better, but I'm going to do that one in the notes. I just don't want you to watch the video of me doing that. That's icky. All right, this one, we condense this side, and plus becomes times. And we condense this side, and plus becomes times. And then we can say these, after we distribute, have to be equal. All right, and I'll come back and finish that one. That one you might get to throw away an answer, so watch for that. Oh, maybe I'll finish it now. If you subtract 8x from both sides, and then subtract the 48, it'll factor plus 12 and minus 4. So make an 8 and a negative 48. So you get x equals negative 12 or positive 4. And if you put a negative in here, you can't do that. So the only one that's going to work is 4. All right, couple quick applications and I think we're done. This says A sub 0 is the initial amount, so how long will it take 50 grams, so that is our initial amount, to decay down to 10 grams, which is how much we want to be present at the end, so that's A. So these are the kind of applications you are going to have to solve, but I'm going to do a whole bunch more applications tomorrow. So you would have 10 equals 50 e to the negative 0.00043 t. Isolate first, so you're going to divide by 50. Then because there's an e, we're going to, and the t is in the exponent, we're going to take the log of both sides, and we're going to use natural log. And then we're going to bring this out in front. So I haven't touched my calculator, so I'm just leaving this 10 over 50, which I know is 0.2, but if I bring this out in front, I have negative 0.00043 t times ln of e, which is 1. So all I need to do is divide by and I'll have t. So the natural log of 10 divided by 50, all in one parenthesis, and then that whole thing divided by negative 0.00043 is 3,742.9. I'm not going to bother around really long here because it is t years. After how many years? So even I would say this is about 3,743 years. Okay? One more. It says the Richter scale uses logs. The function used to measure the magnitude r, so r is our magnitude, which here it says is 6, is this equation, 0.67 log of 0.37e plus 1.46, where E is the energy in kilowatt hours, and we're supposed to find the energy of this equation. So we're going to subtract 6 minus 1.46. Then I'm going to divide, I don't know why I put a parenthesis in there. I'm going to divide both sides by 0.67 to finish isolating that log. Which gives me 6.77612, lots of places I'm going to carry there. All right, now I have isolated the log. This is a log base 10, so I can raise both sides or just rewrite it as 10 to the 6.776 equals 0.37e. So then after I type that, I'm going to divide it by 0.37, and I'm just going to have the amount of energy. So 10 to the power of 6.776 whatever, and then divided by 0.37. It's a really huge number, 161,405 something. So over 1 million was it kilowatt hours, I think? Let me go back up here. This, which I'm sure has an abbreviation. All right, so a lot of energy released by this magnitude 6 earthquake. All right, those are just a couple quick applications and why we need to be able to solve log equations. Pretty sure that I'm done. Let me see, is there another slide or not? I have an extra example here. Oh, just a reminder that when they're not all logs, this one would become a multiplication, and then you would do 12 to the second. Okay, and I can finish that one on the notes for you, but just a reminder that you can't get rid of them all when they're not all logs. Okay, so I'm going to stop the video at 26 minutes, and I'm going to go back and do the ones I skipped on the notes.